Hi everyone, today I'm going to talk about identifying similarity of software in Apache ecosystem, an exploratory study. So let's start with a brief introduction. Software ecosystem, known as SECO, is a set of software solutions. Software from same ecosystems build similar technologies, share artifacts, reuse code, and depend on one another. This means they have interdependence. But some features are not supplied beyond SECO software, leading to reuse interdependencies and external libraries. These external libraries offer different functions, methods, and proceedings that we can reuse for concrete services. Here we have an example for logging functionalities. Actually, most of software depends on the usage of external libraries to provide technical facilities for developing different tasks. Some of the benefits of external libraries are they are well tested, they provide desired functionalities, they improve software quality, they provide cost-effective to build software, and they improve productivity of programmers. Then we have motivation for this work. Use the Apache SECO and similarity metrics to provide useful information about trending libraries for developers regarding ASF categories, and Apache community preferences. To reach our goal, we need some information and concepts. First, the Apache Software Foundation, which comprises more than 160 open source software and suggests 18 categories. The idea behind these categories is to create groups of related projects, but projects can belong to one or more categories. And here we can observe the 18 categories. Now we have Maven, which is a project management tool. Maven projects have a metadata file known as POM. In this file, the required libraries are specified as dependencies. The outline of this declaration is the tag dependency. Each element has three mandatory children: a group ID, an artifact ID, and a version. The group ID means the company, team, organization, or other group. The artifact ID is a unique ID number which represents a single dependency, and a version which is a specific release. Then we have similarity metrics to calculate similarity between two objects and map them into a single numeric value. Two similarity metrics used in this work are Jacquard and cosine. So let's suppose that A and B are two object vectors. In both metrics, similarity values are between 0 and 1, where 0 is total dissimilarity and 1 is similarity absolute. Our study was designed through three research questions. The first one is what is the distribution of projects by category? We perform distribution of projects in categories considering that each project can belong to one or more categories. The second one is what is the similarity degree among projects from same category? Our hypothesis in here is projects in the same category tend to use identical libraries because they may supply similar tasks. And the last one is which are the most used libraries by the projects from the Apache SECO? In here, we identified the most used libraries among projects and the number of times they are used. This study is based on Java open source Maven projects, due to ease for extracting external libraries treated as dependencies into the POM file. We established criteria for collecting and analyzing current projects. These projects were mined from ASF category catalog and manually clustered. So the first one is Java open source Maven projects with more than 3 years of maintenance. The second one is last years of maintenance should be between 2013 and 2014. And the last one is projects must have at least 2 versions released. For data processing, a plugin was developed to process software dependencies, to compute similarity among projects, to calculate the number of used dependencies among projects, and to report the number of times each dependency is used by projects. Now, let's see the results. We obtained 91 projects. These projects were clustered into 14 ASF categories. As one category, male, had only one project, it was not considered. Thus, we obtained and analyzed just 13 ASF categories. On the other hand, for answering the research questions, we used three groups for applying Joker and cosine similarity metrics. The first one is set P with all 91 projects. The other two sets are those with more quantity of projects. We call them a set L and a set NS. So here we can observe the 91 by 91 similarity matrix. In this matrix, the main diagonal corresponds to self-comparison of projects. There were three comparisons between dependencies showing the highest similarity degree indicating total similarity. By manual inspection, we found that JUnit was the only dependency, which is also used in 80 projects. Besides, there were areas with total dissimilarity. For example, in here, we found this project without any external libraries. Moreover, the number of external libraries was computed to understand the reasons for low similarity values. This computation resulted in 2,660 dependencies, where just 695 dependencies are used in at least 2 projects. Here we have the category with more quantity of projects, corresponding to library category, which contains projects meant to be used by other applications. We got two 37 by 37 similarity matrices, corresponding to Joker and cosine. We note that similarity degrees were different between them, therefore cosine metric was discarded. For this set, the same 3 projects from P set presented total similarity degree. On the other hand, 3 projects had similarity degree 0. By manual inspection, we observed that 2 of them just used one external library, and the other one did not depend on any external library. The second ASF category with more quantity of projects is the network server. Projects in this category are those related to anything that acts as a server across a network. We got two 21 by 21 similarity matrices, corresponding to Joker and cosine. We note that similarity degrees were different between them, therefore cosine metric was discarded. For this set, the major degree was 0.35. To understand reasons for low similarity values, the number of used dependencies was computed, and we got 1,368 external dependencies, where just 23% are used in at least 2 projects. Now, let's discuss these results a little bit more. We answered, what is the distribution of projects by category? We found that there are 13 ASF categories with at least 2 software projects. Therefore, the major quantity of projects was clustered in L category. The second category with major quantity of projects was NS category. We can say that 67% of projects are clustered in just one category, meaning that 32% of projects are spread into at least 2 categories. The only category with exclusive projects was beta management. This category had just 4 projects. For this question, our main hypothesis was projects from the Apache C code of same category tended to use the same libraries because they may supply similar tasks. Nevertheless, results indicated similarity degree tended to be low. Hence, we got 2 new hypotheses. The first one is outliers into project clustering. The second one is quantity of dependencies per project is highly disproportionate. Hypothesis 1 is null since ASF categories are not influencing the similarity behavior and trend of dependency similarities were low even with blended categories. For hypothesis 2, we got 74% of dependencies declared by single projects, which certainly caused low similarity degree between comparisons. Briefly, hypothesis 2 is true, and the quantity of dependencies per project is highly disproportionate. To answer which are the most used libraries by projects from the Apache SQL, we made a top 10. This top 10 shows the most used libraries. As we can see, 80 projects used JUnit. This external library is an open source Java framework and is one of the most used tools for Java unit testing. Java code tends to be far more robust, reliable, and bug-free because of JUnit. For these benefits, JUnit is so popular on the Apache SQL. As we can see in here, there are other dependencies for login services. So, it leads to the importance of login configuration and the difficult decision developers have to make since there are so many choices of login frameworks. Finally, we have conclusions. We expected to obtain high similarity degrees among projects from same categories in order to identify and suggest libraries for reusing in development projects. But results presented low similarity degrees among projects because of the disproportionate quantity of libraries. We also found that JUnit and login external libraries will be useful for reusing on development projects for the Apache SQL. Thank you so much for your attention. If you have any questions, comments, or suggestions, you can send us an email.